Afternoon, everyone. How was lunch? Good. I mean, I enjoyed it. It was good. Although apparently there were a bunch of people who decided to take our keynotes out for a garbage plate. I'm not sure if that was a good idea or not. They probably won't get me in a food coma the rest of the day. That's all right. So yes, hi. My name is Richard Smith. I am a senior consultant with Security Risk Advisors. Sponsor booth. You can find them just across the way from where we are now. But I'm here just in my own personal capacity. But just to give you an idea of who I am, I have 4 years of cybersecurity experience. I started out as a defender in our SOC and did some sort of client leadership work in that area. Got my CISA Plus certification, and I've now moved into sort of the DevOps engineering space where I'm doing blue team engineering and onboarding of new clients. Before that, I had 10 years of infrastructure IT experience. I started off working in desktop IT. Have you tried turning it off and on again? And then I moved on to some systems and network administration in a few different fields: pharmaceutical, healthcare, IT, all that good stuff. And then I spent a few years as a virtualization consultant, installing and upgrading VMware, Nutanix, Citrix virtualization, all that stuff. My email is there. I don't really do the social media, Twitter, Mastodon thing, so if you want to reach me, email is probably the best way to go. So let's start with a story. Are we all sitting comfortably? Then I'll begin. So let's meet Jim. Jim, you may recognize him from Dunder Mifflin, but he's actually moved on in life. He's now the CISO. He got his cybersecurity degree, and he's moved on to St. Quentin's Hospital, which is a medium-sized healthcare organization somewhere in the US. Like many organizations, I would dare to say most organizations, they use Microsoft 365 for their email, as well as other productivity tools, but we're focusing on email today. They are a very cost-conscious organization. Like many organizations these days, we're trying to save money, rein in costs. But being in a highly regulated industry, there's that balance to pull between, we have to be efficient, but we also have to meet regulatory compliance requirements and all that good stuff. For the organization, maybe I don't have to say this, but I will. Securing PHI and PII, that's personal health information and personally identifying information, is of vital importance to this organization. It's what you might call a crown jewel asset, to call back to what our keynote was talking about this morning. Jim, Jim is very concerned about the number, the scope, and the cost of business email compromise attacks. I'm going to assume that we basically know what that means, but business email compromise just meaning someone sends a phishing message or some kind of targeted email with a link to malware, or someone tries to sort of social engineer to get someone's password, and a business email account is compromised, and somebody who should not have access to it has access to email, and bad things happen. The cost of a business email compromise and the breach that can happen from that is sometimes really cripplingly high. Because not only do you have the cost of recovering data, maybe if there's malware, you have to do recovery work for that. If you're in a regulated industry, you're also having to deal with things like fines and all of the legal stuff that goes along with that. Obviously, you can see Jim, he's terribly worried about this. And his concern is this: if we had a cybersecurity incident, like, for instance, a compromised user account that has access to a mailbox that contains sensitive information, like PII, PHI, how do you know what the hacker actually saw? Traditionally, for a lot of organizations, due to auditing gaps caused by licensing issues, by which I mean premium auditing, which might give you access to this kind of information, was often behind a paywall. You had to pay, for a premium level of auditing in order to get that. A lot of organizations could not afford that or chose not to invest in that. And so when they had an incident, you can't see what the hacker saw. You have no idea. So you have to assume that the intruder saw everything that they had access to during the window of that unsolicited access. And you then had to report that this person saw everything. And you would be fined as if the hacker saw everything. I'm going to make the claim, and I'm somewhat backed up on this, that most data breaches, particularly email compromise type breaches, are affected by this auditing gap. So let's take a look at some numbers here. Last year, about a year and a half ago now, Perry Johnson and Associates, a medical transcription company based in the US, they had a business email compromise that resulted in a breach, and the data of, that's nearly 9 million patients, was exfiltrated and exposed. Another example from a little bit longer ago, medical informatics engineering, July 2015, similar incident, 3.9 million patients were impacted by that. These are mind-boggling numbers of records that get breached during these kinds of incidents. And you have to think, are they actually breaching all of these records? It's likely that in a lot of these cases, the actual number of records that the hacker accessed is much lower than what's reported. What's reported is everything that they potentially could have accessed, because in a lot of cases, the companies don't have the tools in place to specifically see what they read and what was actually exfiltrated. Water break. So that's what Jim's worried about. But Jim has an idea. What if we could show exactly which emails were accessed by a hacker during a breach, or during an incident, I should say? What if, additionally, Microsoft made these logs available for export to any platform? And also, what if there were some kind of indicators of compromise that could then be leveraged to generate alerts in your company's SIM? That would be pretty neat, wouldn't it? Newsflash, that's what we're going to be talking about today, so stick around. Okay, so get the button to work. So Jim sets his engineering team to work on this. We're going to, first of all, we're going to figure out how we access email audit logs. First of all, you've got to make sure that the logs that you're looking for are actually enabled, and you can do that if you're a Microsoft 365 customer one of two ways. One, you can go to the compliance platform in Microsoft. The URL is right there. Go to the audit log search address there, and you can switch the unified access audit logs on from there. Or there's actually a handy PowerShell commandlet that comes with the Exchange Online PowerShell plugin, and I've included that full command there, and that will just enable those logs to be turned on, and that will start logging all of your Exchange activity. And the source for that is right there at the bottom. So
you're saying there's no cost for this?
That's it's included with your Microsoft 365. You don't have to pay for E5 or anything. If you're an E3 customer or whatever, then this is included. This is just, and Microsoft has worked very hard the last year or two to expand access to that. Previously, it was just limited to Purview Premium, which was an E5 feature. These days, Microsoft is expanding access and making it easier to get to these logs, and that's what we're aiming to get at today. So okay, we've turned on the logs, and the logs are there somewhere in our Office 365 console platform. But how do we see them? We'll find out. How do we interpret them, and how do we store them? There's a couple of ways that we can get at the logs. If you are a PowerShell type, you can use the search admin audit log commandlet from Exchange Online PowerShell. That's really a good way to sort of do a quick and dirty search for something that you're specifically looking for. Or you can get the logs via the Office 365 Management API. A problem with using the UI for this, the Purview UI and the PowerShell commandlet is the logs are not natively exportable. The logs cannot be exported from Purview. You can't. It's a pain in the neck to try and export them using PowerShell. Certainly not designed for that. So to export the logs to a storage blob, a data lake, or a SIM, which is what we want to do if we want to have long-term storage of these logs. Okay, we need to have them in some kind of a database that has powerful searching capability like a data lake. We'll have to get a little bit creative. Fortunately, the logs are exportable using that Office 365 Management API that I was talking about earlier. So Management API comes to the rescue. We're going to need to process, filter, and shape that data so that we get it into a human-readable format in our data lake once we actually get it there. But we can get the data, and we can export it using an API call. So, okay, Jim's engineering team has a plan now, sort of. They know vaguely what they're going to do. In our example here with Jim's team, we're using Cribble as the data processing tool. I just want to point out, I'm not here selling Cribble. I'm not saying that Cribble is the only tool. There are other tools available. This is just what we used in this example. Overall then, here's kind of what our data flow is going to look like. Okay, the big 10,000-foot view. We have our API call application in the middle. It reaches out to the Office 365 API, gets the data from there, and processes and sends that over to the data lake, and also, we have a dotted line here going to the SIM. More on that later. We're not sending everything there, but we will talk about that in a little bit. Okay, so we have our idea. Let's take a look at what the API gives us when we hit it with a request. That's ready to start implementing the solution. Great. We can't wait. We want to see what a post command to this API looks like. This could be the answer to all of our problems. This could make Jim very, very happy instead of very, very worried. This would be a good thing for all of the engineers. So they hit the API endpoint with a bearer token that they got using the API creds that come with their Microsoft 365 account. And they asked the API for some Exchange audit logs. OK. Are we ready? I'm hoping we're ready. OK. Well, let's see those logs. What do we have? We have, OK, I don't know how well you can see that from where you are, but we're not seeing logs here at all. We have a bunch of URIs that point to a bunch of storage blobs in Azure. Well, that doesn't sound right. That's not very useful. They're not logs at all. But each line item in the log, each of those URIs, is a link to an Azure storage blob. Those storage blobs are where those logs are stored. So we're going to have to do a bit of work to get at these logs. We have to have a kind of multi-stage application that will do the call, post to the API, get that list of storage blob URIs for the time period we're looking for, And then we run another API call, a GET request, to get all of the logs that are stored at each URI and forward those onto wherever we're sending them. So it's a two-step process. We also have a couple of other requirements that we need to deal with here. When you hit that API endpoint for Microsoft Office Exchange in Office 365, it's going to return all mail audit logs. Any create, delete, send, all of those logs are going to be coming in. We are only interested, for our use case, in mail items accessed. Not interested in any of the other stuff. So, you can do this a few different ways, but the way that we did this, Jim's team did this, was that we used filtered routes in our data processing tools, in our case Cribble, there's other things available. So we filtered them to only send the mail items accessed log to the data lake. And that route ended up looking like this. I don't know if that comes out very well on that screen, but you can see, so we have a filter, and the filter looks for the input ID, which is the listener that we have for the unified access, which is the name of the audit logs that we're doing. And then we have a second filter in there, so we've got that double and then we have raw includes mail items accessed. And so we're basically saying throw away anything that isn't a mail items access log. Okay, that all makes sense so far? We're good? All right. Okay, cool. We also, and this comes back to what I was saying earlier about sending some of the logs to the SIM. We want to detect throttling. Jim and his engineers have read on Microsoft's Learn website that there's this special feature with the mail items accessed log. If more than 1,000 audit records are generated in less than 24 hours on a single mailbox, Exchange Online stops generating auditing records for mail items accessed activity. Initially, you think, why would they do that? Here's the use case for that, and here's what we're going to be doing here. We can send information on throttled accounts to our SIM. So when an account is throttled, the audit log sends the field is throttled true. It's a flag field, which is set to true when something's throttled. And that's included in the log that it sends. So we can also create a filter and route in our processing tool that sends anything with is throttled true to our SIM. Then we can build the detection rule based on that. Yeah. So, okay, so those are our use cases. That's kind of our requirements. Let's build the app. Let's take this from concept to reality. So, we know how to get the logs. So we authenticate to the API. The API returns the logs. Since the logs are just storage blob URIs, we then send another request to the storage blob to retrieve the logs at that blob. And we sort of iterate through that. And then we send them off to our data lake in our SIM. This way, we can get actionable data on throttled accounts going to the SIM. A SIM, as I'm sure we all know, is the storage on any SIM solution is going to be higher cost, short-term log retention. We want to reduce that log volume as much as possible, right? Because we want to be efficiently using that and not just storing everything in there because it's going to get really costly really quickly. So we only send those throttled accounts to the SIM, okay? Because that's the useful stuff. That's what we can build an alert on. Come on. Technical difficulties, excuse me. Anyway, okay. Why is it?
You've got some other alerts that
Frickin' Outlook, sorry. Outlook's wonderful, we love Outlook. Okay, does that work now? There we go. Okay, cool. Yeah, so we also have the mail items access records, all of them, going to long-term, cheap storage in our data lake so that we can have that on hand for longer term so that we can use that for an investigation and to enrich any alerts that we get. So if we get the alert saying something's throttled, then we can go back into the data lake and see what happened and what kind of activity is behind that throttling. Why did that happen? But we don't have to have it all in the SIM. We just need the alert in the SIM, right? That makes sense so far? You with me? All right, cool. So we can use a serverless function in our cloud solution of choice here, whether it's Azure or AWS or Google Cloud. We can use some kind of serverless function to run this app. The advantage of doing this is we don't need to deploy and maintain a VM or a server to run the app. It's definitely cheaper than running a cloud VM or an on-prem VM. In our case, we ended up using node.js, running in an Azure function app. But most cloud solutions will support any runtime. You could build this in Python, you could build it in PowerShell, you could build it in whatever you like, really. And like I said, you can run this in an Azure, AWS Lambda function, or in your cloud solution of choice. Here's the sort of pseudo code. This is the data flow, how the application is going to work. So we start with getting our token on the top left. We use that token to list the blobs, and then we kind of enter a loop. So we take blob n, we open blob n, we format that in JSON format, and we send that off to our destination. Then we check for blob n plus 1. Is there a blob n plus 1? Yep. Well, we'll name that new blob n and go through that loop until we've gone through all the storage URIs, all the blobs that were in that call. And then when there's no more blobs, we exit. Fairly simple. Makes sense. This is the actual code that we're going to go. So I'm going to go sort of block by block, function by function through the code that we used. And this is all available, by the way, on our GitHub. I'll share the URL for that at the end. So in this first one, this is the get token. This is where we actually get our bearer token. I've abstracted away the tenant ID, client ID, and client secret, because you could hard code them in your environment. I don't recommend it. I would recommend you to do those as environmental variables. But that's how you get your bearer token. Once we've got our bearer token, we can access the logs, or the URIs at least. So then we have our function here to list the blobs. So we're hitting the API endpoint and grabbing all the storage blobs for a particular time frame. And we've got this configured in our in a function app for I think it's every 10 minutes. But you can, this is an environmental variable you can set as to how often you want to trigger it to run. Okay, so it fetches a list of storage blobs for the defined time period. And then we look at that list of blobs and we get each blob. Then we have, this is really two functions, but we have the process blob, which is actually the second one down here, where we download the contents of that blob and we sort of store that. And then we post that blob off to our endpoint, which in our case is going to be either the data lake or potentially the SIM as well, or our processing tool, Cribble in our case. And then once we've got all of those functions defined, then we have our main function here, which runs all of these processes and goes through that whole iterative process that I was talking about in the first flow chart that I showed there. All good, right? This is exciting. We're now at a point, we've got the app, we've got it to do the things we want it to do. Let's sum up. We get a bearer token by presenting our API creds. We then use that token to get the list of storage blob URIs. And then we download the contents of each storage blob, send it for processing and filtering, and eventually we go out to the data lake and sometimes the SIM. Okay, putting it to use. All right, what do we do if there's an actual incident here? Well, let's see, because I got news for you. St. Quentin's, where Jim works, they just got compromised. The SOC team, Jim's SOC, they discovered that there was an attacker who gained access to a user account, and they're able to log in to that user's email inbox. Based on logs from our multi-factor authentication tool, the team at St. Quentin's can see that a request was sent from a suspicious IP, which we've logged, and that it was accepted. So that's how they got in. Okay, even though we've got MFA in place, we were still the hacker was still able to get an MFA token sent to them and accept it. Now, whether that was the user accepting it by mistake or whether it was some more advanced technical method, we don't know. But we know that they gained access through a fraudulent MFA request. We also know that the attacker had access from 7 a.m. UTC, Universal Time, which is 5 hours ahead of Eastern Time, on March 14th. So this didn't actually just happen. This happened a few months ago. I wrote this a while ago. Bear with me. So they had access from that time to 1:30 p.m. Universal Time on March 18th. So just over 4 days they had access. All right. So it's time to investigate. We're going to send over Jim's friend Dwight. He's the assistant CISO, or the assistant to the CISO, depending on the day and who you ask. But he's going to go off on a hunt because we have the IP address of the hacker. We have the time frame of when they had access. So we're tasked now with figuring out what emails did that hacker access, right? Okay. We've also got our is throttled flag to think about, right? So has the is throttled flag been set to true? Do we have a SIM alert for that being true? Because if we did, then the SOC would be all over it immediately. Let's dive into the data lake and take a look. So we discover something immediately. The audit logs that we have in the data lake only identify the email by the internet message ID. It doesn't actually have the subject, recipient, any of those details, but it does have the message ID. We can, however, cross-reference that against the Office 365 email events table if you're using, if you happen to be using Microsoft Sentinel and you have the Office 365 connector in there. You can just do a join query on both of those tables. Otherwise, you can access email events through the Office 365 interface, and you can cross-reference those message IDs. So we cross-reference or join on the Internet Message ID field, which is in both tables, because that's the unique identifier that we can use here. And suddenly we can see the sender and recipient info and the subject line of the emails that were accessed by the hacker during this time period. So this is the actual query. I've redacted information because this is actual client data. But you can see, if you look at the query up here, this is in KQL in ADX, but of course you can do this in any data lake solution using whatever query language they're using. You can see the client IP address is in the first little red box there, so I've placed in there the URL from which we saw the MFA request come in, right? And we've got a join query here, so we've got the Internet Message ID matching, and we've got the time frame as well. So if you look at the second line of that query, we've got our March 14th at 7 o'clock UTC to March 18th at 1:30 UTC. I've got a couple of things there to select which fields I'm gonna have in the table. And if you look at the bottom, so here are the results. I've highlighted in red the client IP address, which is the same in all of these. So we know that that's the client IP from which these were accessed, which is the same as the malicious IP that we logged. And because this is actual client data, I've had to redact it. But you do see the sender, recipient, and subject columns, which do have sender and recipient info and subject line for each of the emails that were accessed from that IP address during this time period. The SOC also had a look, with Dwight's help, they had a look and they found that there were no throttle alerts for that time period. So whatever was going on here, it didn't cross that threshold. All right, so let's take a look. Let's sum up. We knew the attacker's IP based on the MFA logs. We can search the audit logs for that IP address. We can cross-reference those message IDs with the email logs to see what was actually accessed. And now we can report which items were actually accessed from the attacker's IP address, and effectively, we're greatly reducing the scope of the breach that we're reporting. As I said, in this case, the number of records that got accessed didn't end up triggering mailbox throttling, so we didn't see an alert for that. But if it did, if there was another incident like this that did cross that threshold, then immediately our SOC would be notified because we built that custom detection in our SIM that would generate an alert, and our SOC would have eyes on that, very, very quickly. So let's just close out. Kids, do try this at home. This is fun stuff. To sum up, Jim's idea is basically awesome, right? So we've been able to show exactly which emails were accessed by a hacker. We have a way to export those logs to any platform, and we can leverage that is throttled indicator for SIM alerts. So we've solved all three of the problems, all three of the requirements that Jim asked for. So as you can see, Jim and Dwight, they're best friends again. So that's all good. If you want to find out more, we do have the JavaScript code available on our GitHub. Link is right there. And there's a full write-up of this on our blog as well. So yeah, I don't recommend you writing that down, but you can take a photo. And yeah, there's lots of other cool stuff on our blog as well about other aspects of Microsoft 365, purview auditing. We've got a lot of good content on there for that stuff too. The slides will be available shortly after the conference. Yeah, all the talks that we're doing here, the slides will be available online, except for the FBI because we're not allowed. But apart from that, everything's going to be available online. So yeah, that's really all I have for you today. Are there any questions?
So just as an observation point, your early example, the two instances that had happened, one was almost 9 million records, the other one was about 4 million. If I saw your SQL query, you're talking 1,600. That's the power of what you're trying to get to. It was
Potentially, right, yeah.
Like 1,600 records returned, so that would be 1,600 emails that person, the actor actually accessed. That's evidence in proving, that's a significant difference. That's your
Exactly. That's the thing, yeah, because instead of reporting, instead of having to report and get fined for 8.9 million records, you're instead having to report and get fined for, well, I don't know how many, but like a fraction of that.
Like
yeah.
1695.
Yeah. Yeah. Yeah, and that makes a big difference. I mean, especially because, some of these compromises, they...
Of those that had PHI or PII.
Yeah, yeah. And like you said, yeah, even among those that were accessed, did they have PHI? Could they have had PHI? Or was it just, Anyway, I'm sorry, yes?
When you said you're working on the throttling, how would you differentiate between like somebody trying to access a whole bunch of data and somebody, say, rebuilding an Outlook profile or setting up a new computer or something?
Yeah, good question. I mean, so the mailbox items accessed logs when a message is accessed. Which, if you're just rebuilding someone's inbox, I don't think you're necessarily opening the mailbox items.
There's a separate, other than throttle, there's another key value pair that'll indicate that it's the Outlook app downloading everything, as opposed to someone actually adding, like looking at a given email. So if you're doing a repair and it's downloading the entire inbox, there's a different mail access key that
Like another flag. Yeah. Cool.
yes, because if the attacker did that, if you see that same key, you know the attacker's IP address, you see that, that means the attacker just used Outlook and downloaded the entire mailbox, and you're kind of screwed there. I was thinking along lines of filtering out the noise from.
Yeah. But no, that's a potential tuning effort you could make too. Yeah. Yeah, at the back.
Would it be similar for things like OneDrive and SharePoint?
Yep. All of those things, so SharePoint, OneDrive, any of those Microsoft 365 solutions, they all have different endpoints within that API. So you could pretty easily adapt our JavaScript application to hit a different endpoint and get whatever the data is you're looking for, whether it's SharePoint, OneDrive, whatever. Yeah, it's not difficult to do.
Are those storage blobs going to be?
I believe it's all the same. It's all the same thing. It's storage blobs. It's the same method. It's just you're hitting a different endpoint. Yeah. So let's move over here. Yeah.
When Microsoft says they're throttling the audit logs, are they just slowing down how quickly they're writing them, or are they losing some of those logs when it's throttling?
My understanding is they will no longer audit access for that mailbox for the next, I think it's for the next 24 hours. So it pauses. So yeah, effectively, I think you are losing additional reads on that mailbox. But if you're already seeing 1,000 reads on a single mailbox in 24 hours, I think that's enough of an indicator that you want to investigate already.
How would that work for our proof that only X number of email objects were accessed? If we then had that gap to say, well, we know in the first 24 hours 1,000 were accessed, but the next 24 hours we don't know how many.
Yeah,
Which ones?
You might have to
that's a good question. Yeah.
That's still better than all records, right?
Right. Yeah. I mean, that there is. I see that there's a visibility gap there. That's a good one.
You just have to consider the whole mailbox.
Yeah.
At that point, you're looking at the entire mailbox.
Yeah.
That's still a lot better than all records. So only 7 of those are going to have PHI.
Right. Yeah. Yeah. I should probably point out, by the way, that the gentleman at the back who's helping me out quite a bit here is Greg Statura. He's another person at Security Risk Advisors, and he kind of heads up our SOC, and his team does a lot with the detections, and they've done a lot with the throttling detection that we discovered. So that's why he's able to answer these questions better than I am sometimes. Yeah.
How long does Microsoft keep those audit logs going back? Like, 'cause, I mean, if you just wanted to pull the throttle, you didn't want to pull all the audit logs every
Yeah.
time something was in. You wanted to just go back and get them later because you had a problem.
Yeah, so Microsoft, now with the caveat, this may have changed in the last couple of months, but when I last looked into this, they keep those audit logs for 7 days, which is why it kind of is a good thing to export them for longer term storage, because 7 days doesn't get you very far if you're looking at a big potential breach. So, any other questions? Yes.
Does Microsoft give us any ability to adjust that throttling limit? Could we bump that to 5,000 items, or?
The documentation that I've seen on Microsoft's site seems to imply it's hard coded.
Because they're paying for those logs.
They're paying for it. Yeah, but I mean, what I've noticed really in the few months since I first developed and revised this deck is it's changing quickly. So in a few months' time, I don't know for sure, but the answer to that question could be different in a few months' time as they continue to kind of broaden access and make this more of a thing. So yeah, I mean, for now the answer seems to be no, but that could change. Any other questions? Anybody else? All right. Okay. Well, thank you so much. Appreciate it.
We want to thank Richard for his talk today. We've got a certificate and a gift card, and again, you guys got a couple extra minutes. Take a minute. You've got 2 times left.